In this video, we're going to explore 4 different ways Git can merge branches. 1. Fast forward, 2. Recursive, 3. No fast forward, and 4. Squash. If you've ever wondered why your Git history sometimes looks like a straight line, or why other times you see extra merge commits, or how to bundle multiple commits into a single one, this is the video for you. We'll break down each merge method step by step so you can see exactly how they work and why you might choose one over another. By the end of this tutorial, you'll know how to keep a tidy commit history when you need it, how to preserve a detailed record of changes, and how to handle branching strategies that fit your team's workflow. Before we dive into how Git decides which merge strategy to use, let's clarify what we mean by branch diverging. Imagine your main branch continues to receive new commits, while you're also making commits on a separate feature branch. Each branch is moving forward independently. This difference in commit history is what we call divergence. If a branch hasn't diverged, meaning main didn't change while you worked on feature, Git can simply move main's pointer forward in one straight line. But if both branches have evolved separately, Git has to figure out how to combine these distinct changes. Git merge are of 2 types, automatic and enforced by command. Let us look at automatic merges. They are of 2 types, fast forward merge and recursive merge. Fast forward merge. If your branches haven't diverged, meaning the main branch stayed the same while you worked on a feature, Git can simply move the main pointer forward to match your feature branch. This keeps a clean, linear history without an extra merge commit. Recursive merge. When both main and feature have their own unique commits, Git detects a divergence. It then creates a new merge commit that unifies both sets of changes. This preserves all commits from both branches and keeps a clear record of where they joined. Now let us look at enforced by command merge, which are of 2 types, no fast forward and 2 squash. No fast forward. If you want a merge commit, even when a fast forward is possible, Git lets you enforce that using the no-f flag. This means you'll always see a merge commit in the history, marking exactly where the branch was integrated. Squash merge. Sometimes you want to condense multiple commits into a single snapshot. That's where squash comes in. All the changes on the feature branch get merged into one new commit on main. This keeps your history tidy, though it hides the individual commit steps from the feature branch. Let's start with the simplest, the fast forward merge. Imagine you branch off main and call that new branch feature. You make several updates on the feature branch, but leave the main branch untouched. When you're ready to merge back, Git notices that main has no new commits of its own. Since the paths haven't diverged, Git simply moves the main pointer forward to match the end of feature. This creates a straight line of history. No extra merge commit is needed. The recursive merge is also known as a non-fast forward merge. You branch off main into feature just like before. This time, though, both feature and main get new, different commits. So their histories have diverged. When you try to merge feature back into main, Git compares both sets of changes step by step. If there are no conflicts, it quietly creates a new commit that has 2 parents, one from main and one from feature. If there are conflicts, Git stops and waits for you to manually resolve them. Once resolved, you finish the merge with a separate merge commit. This preserves every detail of both branches in a single commit that unifies them. When you try to merge feature back into main, Git compares both sets of changes. Git creates a new commit that has 2 parents, preserving both lines of history. If conflicts arise, you would resolve them manually and then git commit. What if you want a merge commit even when a fast forward is possible? That's a no fast forward merge. Suppose your feature branch has a few extra commits, and main hasn't changed since you branched off. Normally, Git would fast forward main. But if you'd rather keep a clearly labeled merge commit in the history, maybe to highlight that this was a big feature, you can force Git to do so. Instead of simply moving the pointer, Git generates a merge commit. This ensures there's a visual merge point, even if it wasn't technically required. It's a way to keep a record of merges explicitly, making your project history more traceable. Lastly, squash merging. You're working on a feature branch, and you accumulate a bunch of small incremental commits. Perhaps you want to tidy the history so that all those scattered commits become a single, consolidated commit. A squash merge effectively bundles all your commits from feature into one brand new commit on main. The details of each small commit remain only in the feature branch, but the resulting main branch sees just one combined snapshot of changes. This keeps your main history concise, though it can make it harder to trace which individual commit introduced each minor change. Fast-forward merges are clean and simple, but only work when main hasn't diverged. Recursive merges handle diverging histories, creating a merge commit with two parents. No fast-forward merges ensure a merge commit is always created, even if not strictly required. Squash merges condense an entire branch into a single commit for a simplified mainline history. Choose the merge type that suits your team's workflow, whether you prioritize a straightforward timeline, a detailed history, or a tidy commit log. Thank you for watching this week.